Cool. Now, electricity. To sum this up very quickly, when it comes to electricity at VCA, the whole point of this is for you guys to learn about generators and motors. Motors essentially convert electrical energy into mechanical energy, whereas generators convert mechanical energy into electrical energy. They do that by spinning a loop, right, between two magnets, which you will learn later why will generate a current inside the loop. This current can be DC or AC, right? This is what a generator does. For a motor, if there is already electricity flowing through it, through the loop, then it will start moving. But if you start moving it yourself manually, then electricity will be produced inside the loop, right? We care a lot about producing electricity because obviously as a society, we care a lot about electricity, right? We want electricity. So when we have two magnets and we put a loop inside of it, we start rotating it manually, or in a hydroelectrical, water gushes down this circle, causing the loop to rotate really fast, right? Which will create electricity. It's not magic, it's physics, but it will. Right? And once electricity is generated, we want to have the output as AC or DC. AC stands for alternating current and DC stands for direct current. Alright? Now, if you use a commutator, you're going to get DC. A commutator is referring to the rings. If you use a slip ring commutator, so if you use split ring commutator, split, you get DC. If you use slip, you get AC. Pretty straightforward, right? Now some of you might be asking, well, what does that have to do with magnetic field lines going through a loop and a loop rotating the loop, right? Now if you have a current conducting wire through a magnetic field in between two magnets and you rotate it, you're going to get something called flux. And if you get a change in flux, you saw this formula at the beginning of the lesson, right? If you get a change in flux over a particular change in time, you get voltage. Again, not enough time for me to explain in detail why this happens, but this is the formula, right? We also call it EMF. And you need to learn again that an AC current looks like this, whereas DC is only on one side of the x-axis. This is what VCA will ask you to draw. It will say, well, you have AC current or you have DC current. What will the graph look like at the end? And you will basically draw based on whether it is AC or DC. If it is DC, on one side of the x-axis. If it is AC, both on the upside and on the downside. Lenz's law is essentially a law that states how do you determine the direction of the current inside the loop once you put a magnet through it, rather than rotating the loop in between two magnets.